In this video, I'll be going over all the basic hand forging techniques that I use in my videos. So if you're interested in blacksmithing and you want to have a look at how I go about it, stay tuned. Hi, I'm Dennis Frechette and welcome back. In this video, I'm going to be starting a series of videos that I'm going to be referring to as reference videos. They're videos that have a lot of information in them. So I'm going to be time stamping the whole thing so you can go through one section at a time, or if you need to refer back to a section, it'll be easy to find. Uh, all of the videos are going to be listed in the description. As they become available, they will be listed in the main part of the description with a link that'll take you directly to that video. So any of these videos will have links to all of the other videos. Since these are reference videos with a lot of information that you're going to want to refer back to, I highly recommend that you save them to your watch later list, or better still, create a playlist that contains all of these videos. That's what I have for you today. There's a lot to get through, so let's get started. I think we all got interested in blacksmithing in roughly the same way. We found a piece of steel laying around and we stuck it in a wood fire until it got hot. At that point, we would start prying with it or poking the fire or whatever, and we realized how easily the hot end would distort and bend out of shape. And from there, our curiosity grew to a point where we just had to start putting a shop together. So for those of you starting out, here's a video that will show you what you can do with just a hammer, a crude anvil, and a forge. The horn is the cone-shaped part of the anvil that you see facing towards you. You're actually looking at two anvils here. The smaller anvil that I'll be working on is sitting on top of my larger main shop anvil. When I'm working on the horn to create a curve, I'll position the bar on the horn just outside of where I want to start hammering. Which side of the curve that I use to rest on the horn depends on what I want to do. The section of the bar that's sitting on the horn can't move, so if I'm hammering on the far side, I will increase the curve in the bar, and if I start hammering on the near side, I will decrease the amount of curve in that bar, and I can continue that to a point where it's actually back to a straight bar again. So by playing around with different positions on the bar and how much I'm hammering, you can really develop a keen sense for how a shape is going to start to develop. It does take a little while to get used to, but it is worth the effort to learn, because you will find that this is the fastest way to develop a smooth curve at the horn. And the simplest way to practice that is to do what I'm demonstrating right here. You make a simple curved loop, you open that loop back up into a straight bar, and then you curve it back up again. Just keep doing that until the muscle memory takes over and it becomes very intuitive. The classic cross-peen hammer has been proven over centuries of use to be the best all-round hammer for blacksmithing. It gets its name because peen is another word for the striking surface of a hammer, and one of the peens is set at 90 degrees to the handle, so that makes it a cross-peen. The large face of the hammer is divided into three sections. The two outside edges have large radiuses ground in, while the center is perfectly flat. The flat face of the hammer is used to remove any hammer marks from the surface of the forging, as well as drive tools like chisels and punches. When you tip the hammer over on its side, the curved edges will start to dig into the surface of the metal, and that's what allows you to forge the metal very efficiently. The crosspeen, on the other hand, is only used for moving metal, so it only has one large curved face. This is a crosspeen that I bought several years ago in a yard sale. It was obviously used, or at least abused, but it's never been modified into a forging hammer. So it is a crosspeen, but it will not forge metal effectively. It still has very sharp corners on the main face, and the crosspeen is too narrow and it has sharp edges as well. So this will damage the work rather than produce a nice forging. And you can see how the crosspeen is a lot narrower than the one that I like to use. So the point that I'm trying to make here is that it's the shape of the faces that makes it a forging hammer, not the overall shape of the hammer. If you look at this club hammer, you would say, well, okay, well, that's not a forging hammer, but it is because I've modified it into a forging hammer. The main face of this hammer is now ground to match what I use. It has a narrow center, flat face for general work, and then the big curved edges, which allow you to dig into the surface very easily. And the cross peen is not a standard shaped cross peen, but it has a raised center that provides the cross peen effect, and that's all you need. It doesn't have to be that traditional wedge shape. If you compare the two, you can see how the width of my cross peen is actually identical to the width of this. So you don't need to spend a lot of money to get a good forging hammer. This is just a standard hardware store club hammer, but it has the room to grind the faces the way you want them. So that makes it a good forging hammer. I would definitely replace the handle. This handle will kill you, but beyond that, there is nothing wrong with that hammer at all. It'll do all the forging that my hammer would do. Upsetting is a forging process that increases the overall dimensions of a bar by forcing a longer length of bar into a shorter space. The problem is that it takes a fair amount of pressure to force the bar back in on itself, and it takes relatively no effort at all to move the end of the bar out of the way of that pressure. So when you're freehand upsetting, it's a very time-consuming and laborious process because you're always counteracting that tendency for the bar to distort and twist out of shape. Using a light hammer helps a lot because it doesn't have the same driving force as a heavier hammer, so you don't get quite as much distortion, but it still happens and you need to stop, straighten the bar out, and continue. So freehand upsetting is possible and it is a skill that you need to understand and learn, but in reality, it isn't something that's used very often because of the inherent difficulties of doing it without, either at least having a vise or some kind of a forging die to hammer the shape into. Steel is a plastic material, and that means that if you apply pressure to it, it's not going to break. It'll simply flow into a new shape by following the path of least resistance. When you're hammering flat down on a bar like this, the metal is free to move anywhere that it wants. So you'll notice that the bar is starting to flatten and it's growing out towards the sides and along the length, probably in the same proportion. And as I move towards the tip, the shape tends to widen out even more. And that's great if that's the shape you were after, but if you were trying to forge a point, you can see how you have a lot of correcting to do on the one face to get it back in line. So this shape is the direct result of just plain hammering on the surface of a bar. You're not forging anything right now. You're just hammering a bar, see what happens, and then correct it as much as you can, and you keep going. You're making progress, but you're moving sideways as much as you're moving forwards. The solution to the problem is to tip the hammerhead over slightly and use the curved edges of the hammer face to hammer a series of valleys into the surface of the bar. These valleys are called fullers and they force the bar to move predominantly in one direction. So here I've just finished hammering a series of fullers into the face of the bar, and these fullers are forcing the bar to move lengthwise a lot more than it's moving widthwise. The next step in the process is to turn back to the flat face of the hammer and drive all of these high points back into the bar. This not only helps to move the bar longer, but it also creates a flat reference surface so you can determine where you are in the process. So now you have a forging that has transitioned from the original bar stock down to a much finer point over several inches. And that's fine for a lot of applications, like a poker or something like that. But there are a lot of applications where you need to have a transition that happens over a much shorter distance than that. And for that, we use what are called offsets or set downs. It's basically just a well-defined shoulder that allows you to move from one cross section to another very quickly. An offset is a detail that allows you to transition from one cross section to another over a very short distance. They're created by hammering the bar down onto a rounded edge of the anvil. So the fullering process is actually flipped upside down here. The rounded edge of the anvil is creating a fuller, and all I really need to do is just start at the shoulder and start moving the bar backwards very slowly and let the rounded edge of the anvil create this large fuller that just pushes the metal out towards the end of the bar. Once I'm safely away from the shoulder, I can go back to fullering the bar the way I normally would. When you're drawing down, it's always important to be working on a square bar. It doesn't matter whether you started off with a round bar or a square bar, but you always forge it down as a square bar. If you need to turn it back into a round bar, you do that after you get the shape that you want. The reason for that is because a square bar only has two planes of reference. You can turn it 90 degrees and figure out very quickly what's going on with the shape. If you start hammering or fullering on a round bar, then you can have fullers 360 degrees around the bar, and it's really easy to get disoriented and not be able to figure out what you need to do to correct a flaw or a thin area in a bar. So always work with a square section, turn it back to round if you need to at the end. Now that I have this section of the bar sized the way that I want, I can start turning it back into a round bar. And I do that by first knocking down the corners and turning it into basically an octagon shape. And then I just start working around, knocking down any high spots that I see. Now I'm getting ready to turn this bar section into a pretty classic detail that was found on a lot of early ironwork. The end of the bar gets curled back into a nice tight little scroll, and then you forge a standard ring handle at that point from the transition, looping that detail right back around. I'm going to start the ring detail by forging a sharp bend right at the offset, and you can see how that offset plays a role in creating this detail. I've set up a smaller stake anvil in my hardy hole of the main anvil, and I'm going to be using that to forge the actual ring. I'll be using the same techniques that I demonstrated earlier. If you look at the top left of the screen, you'll see that I'm cooling the very end of the bar, and this is going to allow me to hammer that section without distorting that tight scroll. Here you see another example of the same detail, and you'll notice that the horn doesn't really need to be round, and it doesn't actually need to be a horn. This is just a short piece of T-iron that I got in a scrap pile, and the edges are square, but that doesn't matter because I'm not forging on those edges. I'm just using them to support the work. So as you can see, it's possible to get work done in a lot of different ways, and you quite often don't need what would be considered the official tools to get the job done. Having a clear understanding of what you need to do is the main piece of the puzzle that you need to have to create these inventive solutions to solve the problems that you come across on a daily basis. In this example, I'm going to be forging another offset, but this time I'm going to be leaving the heavier section of the bar right at the end, and I'm going to forge the main part of the bar down to a thinner cross section. Once I have that shoulder established, I'm going to be able to use the cross peen, and this time I'm going to be fullering along the length of the bar. So that's going to cause the metal to forge across the width of the bar, and it's going to create that large oval backplate that was so common in early hardware. I use two different methods for punching a hole into hot metal. If I'm punching a small hole that is less than 1/3 the width of the bar and I don't need to enlarge that hole after it's punched, then I will go ahead and use a round punch, punch the hole, and leave it at that. If I'm punching a hole that needs to be enlarged, or if I'm punching a hole that needs to be quite a bit wider than the actual bar, then I will go to a two-step method where I first cut in a square slot that is along the length of the bar, and then I'll use a drift to size that slot into a round hole. And the two-step method is what I use mostly because it allows you to punch any size hole in any size bar. Here you see a sample that I've made up that I use as a teaching aid to help people visualize what size of hole that they need for, say, a handle or something like that. Here I'm using a very low heat to just set up the punch. All I'm trying to do here is establish the location and to sink the punch just very slightly into the surface. And that's going to allow me to find it very quickly when I pull it out of the fire. So now I'm ready to actually drive the punch into the metal to create the hole. So I'll keep hammering until it feels like I'm hitting the surface of the anvil. But I know that I'm not actually that far into the bar yet. What happens is the metal that's trapped underneath the tip of the punch and between the anvil cools very quickly, and that stops the punch from traveling any further. So what I need to do is reheat this whole thing, and then when I come back, I'll be able to punch right down to the surface of the anvil because I'm dealing with hot metal at that point, not metal that's been cooling while I was driving the chisel down to that point. That should give me a hole that only has a paper thin layer of metal on the very bottom of the hole. So to get rid of that, I'm going to flip the whole piece over and drive the punch back through from the other side, and that will shear out that little slug and leave me with a clean hole. Or at least that's what happens when nobody's looking. The slug is actually free, but there's a ragged edge in there somewhere that's hanging up, so it just needs a little tap to break it free. I'm going to start sizing up the hole by punching in a round drift that has a chisel tip on the end. That will make the transition from the slot into a circular hole, and at that point I can use the actual drift that I'm going to use to produce the final size of the hole. Another variation of the slot punch is a hot cut, and hot cuts have a very narrow profile, so it takes very little effort to drive them into the bar, and they're used, as the name suggests, to cut off a section of bar that is no longer needed. Hot cuts can have a beveled edge the same way that a cold chisel does, but I prefer to use mine with a square, flat face. That way I can use them on the anvil without any danger of cutting into the surface. Another use for the hot cut is to create a split on the end of the bar. For example, if you wanted to make a cooking fork or something like that. Again, exactly the same technique. You're just running along the length of the bar for as long as you need, and that creates the two legs that you're going to need to forge into a fork. So there you have it. There's the basic collection of techniques that I use to forge simple hardware and tools. Hope you found it useful, and don't forget to save it into your watch later or create a playlist for all of the videos in this series so you can refer back to them often.